Okay, so I have another improper integral here with an upper limit of integration equal to infinity. So again, let's replace this with, or let's replace this as the limit as b goes to infinity of the integral 1 to b Okay, we focus our attention now on this. Let's do a u substitution because I see e to the x squared and an x. I think I can change this to an easier definite integral by doing this substitution. So let's call this, let's let u equal negative x squared. Let's let du, which means I can replace x dx with x dx can be replaced with du over negative 2. And of course my u can replace negative x squared. And that should leave behind a pretty, hopefully reasonable, definite integral. So I get the integral from, we'll change that later, so it's going to be e to the u. And then x dx gets replaced with du over negative 2. So I'm going to do this. And then let's do we have to update our limits of integration, right? So this was an x, that's an x. So if x is equal to 1, looking at our relationship here, that means that u is equal to negative 1. And when x is equal to b, that means, u equals negative 1. That means u is equal to negative b squared. But now this antiderivative is easy. So this is the negative 1/2. The antiderivative of e to the u is e to the u, evaluated from negative 1 to negative b squared. Okay, and so this becomes negative e to the negative b squared divided by 2 minus negative e to the negative 1 over 2. So then the question is, all right, so our attention now is all on what happens to this expression. What happens here, the one involving a b, as b goes, oops, sorry, I dropped my pen. As b goes off to, right, as b goes off to infinity. Well, let's rewrite this as, make it a little easier to understand. E to the negative b squared, this can be written as this, 2 e to the b squared. And as b goes to infinity, this expression goes to 0, okay? And so that leaves behind this term here, which is plus, minus minus a plus, so this is 1 over 2e. And that's answer choice B.